do, this afternoon, this is the second session that we are having, second and the last session. And you will be writing the team competition this coming Saturday in a few days' time. The first session, I tried to give you some training in the individual paper, which you write alone, 15 questions in 1 hour. And this session here is, I'm trying to give you some training in the team paper. And, as expected, the team paper would be much more difficult than the individual paper, because the 10 people in a team will collectively try to answer the 10 questions which are given. 10 questions. Each question is worth 100 marks. And all you have to do is there's no multiple choice. You have to write down an answer. One answer, right? Whatever the answer is, you have to write it down. It's not necessarily a whole number, I think. But so just make sure that you got everything checked thoroughly before writing down the answer. Sometimes you might write down an answer which doesn't really deal with the question. So, and you can do 95% of it, but you will get 0 out of 100. So make sure whatever answers you put down on your team paper is you are thoroughly convinced that that is going to be the answer. Okay, no negative marks, so that's okay. All right, so I'm going to go into these questions. They are very, very interesting questions. Although I say they are difficult, but if you will see that all of them are doable, but it's just a matter of thinking out of the box. Very interesting questions. All right, so let me go straight to the very first question that we want to tackle. And that is this question. Hopefully you have seen these questions and have attempted them. So I'm going to assume that, and I'm going to go quite fast because we have many questions to do. All right, so this one, you've got a person who's traveling from a town A to town B, and he walks on flat land, and he also walks on hills. Okay, so I'm going to model this thing like this to say that he's traveling on flat land, starting from A, and then he goes uphill, and then downhill, and again he travels on flat land. But I'm just going to put all the flat land on this side and the hill, uphill and downhill, separately. Now, why? There are 3 types of terrain that he travels on. And in each of these terrains, he can travel at a certain speed. And that is what is given here. He first walks on flat land, he walks here, and then further uphill, as you can see, goes uphill until he reaches the town B. And I'm going to put down the town B here. So this is A, and this is B. All right, so then he returns to town A along the same route. So he goes up this way, that way, and that way, comes back to A. So he goes to B, and then he comes back to A via the same route. His walking speed on flat land, the speed on flat land is 4 km per hour. Right? So this is his walking speed here. He walks uphill at the speed of 3 km. And then he walks downhill at a speed of 6 km. So, as expected, he can walk faster downhill. Now then, after that, he returns on the side. Now, we don't know for what distance he travels on flat land. We don't know that. But if his entire journey takes 6 hours, what is the distance he walks between town A and town B? Now here you got 3 different distances. Got no information is given about whether any of these 2 are equal. And even here, you might think that these two may be equal, but it need not be. Sometimes you have a hill like that, and then you have a long like that, you see, still going downhill. So there's no guarantee that these two lengths are the same. So let's give names to these lengths. We'll call them A, B, and C in kilometers because the speeds are given in kilometers. So all the distances will be in kilometers. And now we need to find, the question is, what is the total distance it travels? So the question is, what is A plus B plus C? You also know that the entire journey takes 6 hours, right? Going and coming. All right, so let's see now, how do we do this? So we know the time that it takes for the entire journey, and we know the speed at each sector. So we can work out the times that it takes for each of these sectors. So what do you have? You have the time that it takes. This is the speed. Speed times time is distance. So A is equal to 4 times the time. So the time itself is distance over speed. So the time that it takes from here to here, let's work out the different times. There's a time here, there's a time here, there's a time here, and also backwards, time here, time there, time. There's 6 times. I'm going to work out each of these times. So the first part here is A over 4. Distance over speed is equal to the time. This is the time it takes on the flat land. And here, it'll be B over 3 because it travels for B and speed is that. And then it's coming down a distance of C at a speed of 6 kilometers per hour. Right. And then now he walks back. Now this time, he walks from here to here. You might be tempted to say it's going to be C over 6, but it isn't because now he's going uphill here, you see. So his speed, when he's coming back on this side, will be C over 3. We C over 3. And then when he's coming down here, it'll be B, but now he's traveling, he's going downhill, so it'll be B over 6. All right? And then the last stretch is going to travel the same distance, A over 4. Now, this is the total time that it takes, and this is equal to 6 hours. Right. So you've got an equation involving A, B, and C, but we need to find out what A plus B plus C is. So let's put all the A's together. These two quarters, quarter of an A is A over 2. 2 quarters is an half. And then you got a B over 3, and you got B over 6. Now 1/3 plus 1/6 is a half. So that those two will give you B over 2. When you take 1/3 of B and 1/6 of B, you get half of B. And again, the same story here gives you a half of C. Right. So you got 6 is equal to A plus A over 2 plus B over 2 plus C over 2. Beautiful, because now you can multiply right throughout by 2 to get rid of the fractions here, and you'll get 12. And that is exactly what we needed to work out. 12 kilometers. Beautiful problem. You didn't have to know what A is, or B, or C, but you can use the information to calculate the total distance, right? Regardless of how much each one is. So that's the solution to this problem. As I told you, they are very nice problem. And this is doable, right? Because the only thing you use is distance. Speed times time is equal to distance. No other complicated mathematics. Okay, so the next one is this one. A bag contains, no, yeah, this question 2. Right. The 5-digit number is placed at the front of a certain, the digit 5, is placed in front of a certain 5-digit number. So you got a 5-digit number. I'm just going to put a little box here like this. Got 5 digits. And then if you put the 5 in front, you do that, then it forms a 6-digit number. Yeah, as you can see. Now this 6-digit number is 4 times. This is equals 4 times. 4 times what? 4 times the 6-digit number that would have been obtained if 5 had been placed at the end of the 5-digit number. So it's 4 times. If you take your 5-digit number now, and suppose you put your 5 at the end of that. So this is what you got. 5 times your 5-digit number is equal to 4 times. Not 5 times. This 6-digit number is equal to 4 times this other 6-digit number, which is obtained by putting 5 at the end of your 5-digit number. Okay, now, what is the sum of the digits of the original 5-digit number? Well, again, it looks like a very difficult problem, but you have to give names to unknowns. So let's call this thing here, let's call it n. That's your unknown. The same thing is here, right? So you've got this number is equal to 4 times this number. Now, let's have a look at this. You got 5 and you got some 5-digit number. Let's just put some figures here. So suppose you put 2, 4, 3, 9, 7. And now this is your original number. Sorry. This is your original number, 2, 4, 3, 9, 7. And I stick in a 5 here. Now, what is this new number? How do we write it? You see, it's actually equal to 5 with 5 zeros, 5 zeros, plus your original number, 2, 4, 3, 9, 7. So this is, you can think of this number in terms of your original number. You can write it like that. It's 5 with 500,000 plus your original number. So what does this mean? It means that this your question is, so this number here is 500,000 plus n, as we see here. So when you stick it 5 in front, this is how this is the new number that we've got. Now this is equal to 4. Now in this case here, you got 2, 4, 3, 9, 7, and you got a 5 at the end. So how can you write this? This is, if you think of this, this is actually 2, 4, 3, 9, 7 with 1 0, and you add 5 to it. So in other words, it's 10 times your original number. So this is 10 times your original number plus 5. So this number here is 10n plus 5. Okay, so this, so but by just putting in numbers at the end and the beginning, you have to ask yourself exactly how is that number changing? And this is what we have been doing. And we see that you've got a nice, lovely equation here now. Oops, what happened here? Very strange. Okay, let's work out this equation here. I can't seem to be rubbing this thing out. Clear all drawings. Not even clearing all the drawings. Okay, I have a problem here. But let's just continue with whatever you got. So here, if I look at this equation, I've got 500,000. Sorry, not sure what happened here. So you got 500,000 plus n. Let's bring all the n's to one side. I'll take the n's to the right-hand side first. So you got 40n minus n is 39n. If I took this to that side, right, and bring all the numbers to the other side, so here you got 500,000 on this side. You bring in 4 times 5 is 20. But take it to the other side it's minus 20. So you got 39n. So 500,000 minus 20 is 499,980. Right? That's 20 removed from 500,000. So therefore you can find n, you see. All you have to do is to divide right throughout. Now this thing factorizes is 3 times. Let's divide by 3 throughout. And this, it turns out that this is a multiple of 3. Because when you do this, you get 16666. That's what you get. Okay. And that's 13n with a 0 at the end. So n, you have to divide this by 13. So let's divide this by 13. 13 goes into, I'm going to do it mentally. 13 goes into 16 one time, remainder 3. 13 goes into 36 two times. 2 13s are 26. Remainder 10. 13 goes into 106 8 times. 8 times 13 is 104. And there's a 2 there. And 13 goes into 26 two times. Exactly. So that's beautiful. So n, there's a 0 at the end, is 12,820. And the question is now, if you just wrote down 12,820, you'll get 0 out of 100, despite the fact that you worked out all this. Because the question says, what is the sum of the digits of the original 5-digit number? So you have to add up all these things, and you get 1 plus 2, 13. All right. So this is a nice, interesting one where how do you write a number? See, generally, if you've got a 3-digit number, ABC, right, 386 is 300 plus 80 plus 6. So you can retrieve your digits when you do it like this. Because this is 3 times 100, 8 times 10 plus 6. So this one here will be 100A plus 10B plus C. Now this is not a product here. This is a 3-digit number. Often I put a bracket like that to show it's a 3-digit number, not a product. So you can actually write it like that. Whenever you have 2-digit number, you'll say A, B, you'll say this is 10A plus B. 3-digit, it's like that. All right. But this time here, we didn't have to do all that because we said there's only one unknown. We haven't got 5 unknowns. All right. So that takes care of that. I'm going to now get to the next. This thing's going to remain with me right throughout. I'll have to do something about this. I seem to have written something here which doesn't wipe out. Let's just see if I get to the next slide. Ah, good. The next slide is clean. Okay. A bag contains 50 Rand notes, 100 Rand notes, and 200 Rand notes. So I got a bag with several notes in it. So you got 50 Rand notes, and you got 100 Rand notes. Now you see, again, I got the same problem here. And you got 200 Rand notes. Okay. Now, if you remove 24 notes at random from the bank, so you just close your eyes and pick out 24 notes, you would have taken out at least 5 50 Rand notes. 5 50 Rand notes, 800, 100 Rand notes, and 200 Rand notes. But you removed 24 notes. You got, so in the amongst those 24, you will have 16 of them. You will always have at least 5 of these, at least 8 of these, and at least 3 of these. So now that's an interesting question. Now we have no idea how many there are of each, right? But you'll take out at least, you could have 20, 15 Rand notes for all you care. But having taken out these 24 notes, right, you will see that you've got 5 of them in your hand. So we don't know how many there were originally. See? But after taking them out, you would have at least that. So it says that it's giving a grand total of X rands in the bank. So suppose you had originally, you had say A 50 Rand notes in this bank, and B 100 Rand notes, and C 200 Rand notes. We don't know how many there are. So what happens is that you've taken out, so you've got an equation. The grand total of this is X. So X is equal to 50A plus 100B. You got B 100 Rand notes, and you've got C 200 notes. Okay. Now, they say that you've got at least, in your hand, you got at least 5 50 Rand notes. Okay? So suppose you have taken out, suppose you removed, right? Now we don't know how many 50 Rand notes, but it's at least 5. So it's 5 plus A. No, not 5. It's 5 plus something else. It's 5 plus some number, where P is greater or equal to 0. Because they say at least 5, you see. So you removed more than 5. So suppose you removed 5 plus C 50 Rand notes, and then we say 8 plus something else now, 8 plus Q, 100 Rand notes, and for 200 Rand notes, it's 3 plus R. I can tell you, if it's any consolation, it took me a very long time to solve this problem. Only towards the end, I've noticed that this strategy is very good, where you say you got at least 3, at least 5, at least 8, at least 3. So suppose you removed that amount, where P and Q and R are all positive numbers, because you removed at least these. You could be 0, because in which case you have removed exactly 5, but you have removed at least. That's a catch here. Okay, suppose you removed all this. So what is the smallest possible value for X? So if you removed all this, remember you removed altogether, you removed 24 notes, right? So in other words, the total of these when you add these, you're going to get 24. Right? Because you remove 24 nodes altogether, right? So what happens here? You got 5 plus 8 plus 3 is 16. Yeah, I'm sorry. You see, A will be equal to this, right? A, that means the bag has got at least 50 rand notes. And this is B, and this is C. We are saying that the total number of notes here will be 5 plus something, right? So this is actually A, B, C. So you've got A plus B plus C is 24. So 24 is equal to 5 plus P plus 8 plus Q plus 3 plus R. Or if you just make this A, just leave this as A, then you got A is equal to 24, and here you got 11 plus Q plus R. So it's A is equal to 24 minus 11 plus Q plus R, which means that it's equal to 13 minus Q minus R. So A is the number of notes you had in your, the 50 rand notes you had in your hand on removal, right? And B is that on removal, and you removed C notes. So A plus B plus C is 24. Um, I'm not worried about how many notes there are in the bag. So just be careful. It's just whatever you have removed, you want to know how many 50 rand notes have you removed, how many 100 rand notes, and how many 200 rand notes. So we know that the 50 rand notes will be at least 5. So A will be equal to 5 plus something. All right. So you got this. Now, so what is X? X will be equal to 50. Now I've written A in terms of Q and R. Right. So I'm going to, so I've sort of eliminated the P there. So you've got 50 into 13 minus Q minus R, right? That's the total number of 50 rand notes you got in your hand is that one, we calculated. So that the value of X is, this is the amount that you are, grand total. And then you have B is 100, B is 8 plus Q. and C is 3 plus R. So actually, yeah, actually you've got that, yeah, A is the total number of 50 Rand notes you had in your bag in the first instance. Okay. So this is what the total amount of money you've got here. And when you work this thing out, you'll see you've got so many unknowns, but you got 600 here plus 800, which is 1400 plus 650. So this is 2050. And then you got minus 50Q plus 100Q. Here's a 50Q. And minus 50R plus 200R, which is 150R. Now, you may be quite lost wondering what the heck is Prof doing here. You see, the question is, what is the smallest possible value of X? So I'm trying to analyze X now. I got X is equal to this, right? I want to see what is the smallest possible value of this, right? And I know that this is at least 5, and this is at least 8, and this is at least 3. And I I just put all these equations together and use the numbers, and eventually I've come to this thing here. I've replaced A and B and C by those extra numbers over and above 5, 8, and 3. Right, now I want to know what's the smallest value of this. Now this is easy to solve. At this stage, you can find out what the smallest value of X is, because to make this thing as small as possible, you have to make both of them 0 here. For smallest X, Q equals R equals 0. So these both have to be 0. Any other value will give you something bigger than X. So the smallest possible value of X is actually 2050. And that is 2050 rands. These are all in rands, right? That's the smallest amount of money you would ever had in your bag. It could be more, but this is the question is what is the smallest? So, uh, at, and you to do that, you'll have to say that the number of Q is 0, R is 0. So your bag would have had to have exactly 8 100 Rand notes and exactly 3 100 Rand notes. And uh, then you got 24 altogether. So you got A, B, C would have been, these are exactly 8 and 3. So you got 11 of these because you got 24 altogether. Okay, but that's not so important. What is important is what is the smallest value of X, and that's the answer. All right. So that's a rather difficult problem. As I told you, I took a long time to solve this. So although I come here and make it look as if I know all these things, the fact of the matter is I don't. Because it takes me a long time to solve these. But then there are 10 people who are working on these 10 problems simultaneously. So I don't feel too bad about that. I'm doing it alone. Now here you've got A squared minus B squared is 43, C squared minus D squared is 47. And these are positive integers. And that's a very big plus. You know that they are positive integers, right? So A squared minus B squared, you know very well, that's A minus B into A plus B. And C squared minus D squared is C minus D into C plus D. And that is 47. And these are integers. So you got a factorization of 43, but 43 is a prime number, right? So you got factorization. So a prime number, the only factorization you have is 1 n itself. That's the only factorization. So 1 will have to be the smaller one. And obviously a minus b is smaller than a plus b. So there you get a minus b must be equal to 1. A plus b is equal to 43. And then when you solve for these, you see that a and b will be, when I add this, I'll get minus b plus b cancels off. 2a is 44, a is 22, and b is 21. So you'll see that 22 minus 21 is 1, 22 plus 21 is 43. So you can solve for a and b. And likewise, you can solve for c and d. I'm not going to do it because we need time to work out all the other problems. Exactly the same thing. And there you will see that c minus d is 1, c plus d is 47, and you will have c is 24, and d is 23. Right? C minus d is 1, and c plus d is 47. So you got all these values. So now you got A, B, C, and D. But the question is, what is this funny thing here? It took a long time to calculate all this, to know where A is, what B is, and so on. But when you look at this carefully, you'll see you can factorize this. A into B plus C. If you group those two, plus, if you group those two, D is common. So it's D into B plus C minus 4. And this factorizes nicely. B plus C is common factor. A plus D minus 4. Now this will simplify your calculations considerably because you have to multiply only 2 numbers. Well, here you have to I have 4 multiplications. So this will help you. You can do it like this, but it'll take you a much longer time. You observe this, you can factorize it. It's a power of algebra. So B plus C, you can see what B plus C is. B is that, and C is that, and so on, etc. And I think eventually you get 2021. Interestingly, I think that is the year in which this question was framed. Right? So whoever framed it was a very clever, very beautiful way of doing it. But the fact of the matter is 43 times 47 is 2021. So this was, he just played around and created a nice, interesting problem around this. Okay, so that's the answer. Now, the next one. So just to recap, this is simple. You got a product of 2 numbers is equal to a prime number. So the smaller number must be 1. The bigger number is, the prime number itself. And after that is just simple algebra. Okay. So sometimes you have an easy question. Even in the STEAM one, and then the person who has finished the thing quickly can go and help others. There are about 40 or 50 teams which take part, by the way. And then at the end, they will tell you where you are rated, whether you are 20th or 31st or 1st or whatever. So you must try to be amongst the top 10. If you're in the top 10, you should feel very pleased. There was a time when our teams, when I say our teams, the teams that I trained came first. So that was very nice. So you guys have got some training, but not much. But at least you got some idea of how to proceed with these problems. Okay, let's go ahead. I must stop rambling. Question 5. 3 cards, each having one of the digits 1 to 9 written on it. So you don't know what digits there are, but you got 3 cards. Oh, you see again. You got 3 cards, and one of these digits is, you know what digit, what this is. Let's just call it A, B, and C for the moment. Now they are arranged to form different 3-digit numbers. So I've got 3 cards. You can form a number like this. ABC is a three-digit number, or BAC, or CAB, and so on. But at the end, you want to know the average of the lowest two numbers and the largest, the lowest two numbers. So we better name these things. We'll name these. Osondo, please. Osondo is disturbing the class. So I can say that A is smaller than B, smaller than C. I'll just arrange. There are three cards. They are different numbers. So let's assume A is the smallest, B is the next one, and C is the largest. And that way now I can talk about the two lowest numbers that I can form. Like for instance, now suppose I had 387, 3, 8, and 7, right? Now what is the largest, what are the two lowest numbers? The two lowest numbers will be uh, well, it will have to be 378 will be the lowest number, and 387 will be the second lowest number. Right? All the other numbers are bigger because you can have 873, 837, and so on. These numbers are all bigger than 800, 700, but the smallest numbers will be the 300s, and these will be the two lowest numbers. So bearing that in mind, you can see that I'll have to put the two lowest numbers will be see, it's nice to put a number, actual numbers and figure out what's going on. Then you can generalize. So the smallest two lowest numbers will be, we'll have to have A in the front, right? And then we said 378. So it's A, B, C is the smallest number you can possibly have. A is smaller than B, less than C. And the one just before that will still start with A, right? But then it will be these things mixed around. Now, this is a three-digit number, so I'm going to just use what I told you earlier on, that these are not products. So this is the ABC and ACB are the two lowest numbers, right? So now they tell you the average of the lowest two numbers you can form is 388. Now, we can work out the average of this. What is this number? Earlier on, I told you this number is actually 100A plus 10B plus C. This is a three-digit number. This is like 300 plus 70 plus 8. And the other one is 100A. No, it's 100A plus 10C plus B, because I've just switched these around. Now this is the actual number, right? The actual value of the number in terms of A, B, and C, in terms of the three digits. And these are all digits, A, B, and C. Now the average of this number is, you have to add these two. So you get 10B plus B is 11B. 10C plus C is 11C. So when you add these two, you get that. And the average of the two is, you have to divide this by 2. Right? The sum of these two divided by 2. I can divide this immediately. You get 100A. But this one here, you can't work out what that is. We can just put 11B plus 11C over 2. Right? It turns out that this is the whole number. Okay, but 11 is odd. So it looks as if B plus C is even. Okay, the two lowest numbers have an average, which is an whole number, because they say it's 388. Right. So you got 100A plus this gadget here is 388. Now the question is, what is the largest number you can form? So we need to know the largest possible number you can form. The 100 digits will have to be the largest of these three, which is C, and then B and A. So this is what we're looking for. So we need to know what C, B, and A are. Right? Or what A, B, and C are. Now, we are at the stage here. It looks as if A is 3, and this part here is 88. But we don't know, you see. This need not be 3. If this is more than 100, right? It's quite possible. This is more than 100. Then A, which is your 100th digit of your original number, need not be 3. It could be 4 or something, because the entire number is 388. So we'll have to analyze what this is. Right? This A will be 3 if this part here is smaller than 100. Then we know it's 100A plus a number was smaller. But is this smaller than 100? So let's analyze that. It's 11B plus 11C. Is this smaller than 100? We don't know what B and C are. They are digits. But let's just take out the 11 as a common factor. So it's 11 over 2 into B plus C. Right? Now, we want to know whether this is smaller than 100. If it's smaller than 100, then we can say A is equal to 3. Right? Is it smaller than 100? But what is the largest possible value we can have for B? B, this is a digit, you see. So the largest value for B is 9. Or for B plus C, it has to be 9 plus 8. Right? Because these are digits, they are different digits. So the largest possible sum you can have with those two different digits is 9 plus 8. And that actually gives you 17, what is it? 93 and a half. Ah, that is less than 100. So the largest possible value you can have for this quantity is 93 and a half, which is less than 100. So why do I need that? Now, if I know that this is less than 100, then I can say that A is equal to 3 from that. So therefore, A is equal to 3. You might have guessed it, that A is equal to 3. That's fine, because you'll come to the right answer. But I'm trying to show you that that you can actually prove it. Right, if this is 300, A is 3, you got 388, so this part here is 88. Right, the remaining part. So 11B plus 11C over 2 is 88. Right, sorry, I'm writing all over the place here. I don't think this will rub off. Yeah, I thought so. So we are at the stage here, 11B plus 11C over 2 is equal to 88. So 88 times 2 is 176. So you got 11 into B plus C is 176. And 176 divided by 11 is exactly 16. So you got B plus C is 16. So we don't know what B and C are. But the question is, what is the largest number you can form? So now we want to know what is the largest possible number you can have with A equal to 3 and B plus C equal to 16. Remember, B and C are different. So you'll have to have B is your tens digit and C is your units digit. So when you add these to them, different ways of adding, you get to 16. But since they are digits, you can only have 8 plus 8 and 9 plus 7. Only two possible ways you can have. So you got to have 9 plus 7. You can't have 8 plus 8 because they said all the digits are different, you see. So all the information they give you have to use. So you can't have B and C be equal to 8. So one of them, B, comma C, has to be 7, 9. So B is 7 or C is 9. But the largest possible number you can have is not 379, but 397. Right? The tens unit must be bigger. That's your answer. Because we don't know what B, we only know B plus C is 16. So we know that B is 7, C is 9, or B is 9, C is 7. But you'll have to have B equal to 9 because that's your tens digit to get the largest possible number. So there's a lot of logic that you have to use. You have to keep thinking of what the problem is. Can't listen to don't work, go blindly into trying to solve it. Always bear in mind what your questions are and what you're trying to do and what your goal is. All right. So that finishes that. And then now I want to get to the next question. This is question 6 now. All right. So question 6. Okay, so there it is. 4 men stand side by side, all facing the same direction. I said, all face the same direction. Okay, well, either they are facing right or facing left. So we will use the symbols R and L to depict the direction. So suppose they all face the same direction. So they're all looking at, say, suppose they're all facing right. Okay. Now each of them randomly chooses a direction. So this guy here, he chooses a direction. It could be right or left. So either left or right. So you might just decide that this R, he might just decide to remain as he is. So it turns in his chosen direction. So they all face this way, and he's already facing right, so it turns in the direction. Actually, it's I'm putting it wrongly. These guys are actually facing us. And so this fellow may turn left, or he may turn right. Right? So each of them may turn left or turn right. So the question is not very nice. If you say just facing up, and then they choose a direction, so each one will turn into left or right. Okay, so you might have a combination like this, LR, LR, which means that this guy decided to turn left. So if he turns left now, that means he's facing this direction. And this guy decided to turn right, faces that direction. This fellow will turn left, faces that direction, and this will turn right. Right. So in this situation here, this is how they are looking. At the same moment, altogether they turn in the same chosen direction. Now, what is the probability that no man is then standing face to face with someone next to him? Right. So in this case here, you can see that the R is facing L. They're looking at each other, right? Because you can see this one is looking this way, that guy is looking that way, they're looking face to face. So this one here is not allowed. We want to know, count the number of times you have. So essentially, count the number of times that you don't have an R and L occurring like this. If you got R and L occurring in the sequence, then you got two people who are facing each other, right? So you don't count that. no man is then facing face to face next to the person. So, like for instance, this one here now, R, the one that we chose originally. Here you can see this is allowed because all of them are facing, each one is facing the back of the other. So they're not facing the, so this is allowed. So we'll count this kind of a thing, but we don't count that one. All right. Now, what are the possibilities? This is the question. There are so many possibilities because each one can choose a direction. You can choose left or right, left or right, left or right, left or right. So there are two possibilities for each one of them. So altogether, the number of possibilities is 2 times 2 times 2, which is 16. Right. We can actually write down the whole 16 possibilities. I'm going to do it now. So how do I do it? It's going to be, how do you write down all the possibilities, these sequences like this, right? Without making sure that you don't leave out anything or you don't count anything more than once, right? There must be a systematic way of doing it. Now, the way I do it is I'll just choose the first two to be both L, right? In that case, I can have four possibilities here. I can have LL, or I can have LR, or I can have RL, or I can have RR. Right. LL, LR, RL, RR. Right. That is when the first two are LL. Okay, so suppose now the first two are LR. So I put LR, 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 and do the same thing here. Then you get LL, LR, RL, RR. Right. Now that's when the first two are LR. So if the first two could have been RL, I'll put it 4 times. And again, you have LL, LR, RL, RR. And likewise, the last one is RR. And again, you have LL, LR, RL, LL. Right. So there's your 16. Right. So, so here, you want to count when are they, no man is left facing face to face next to him. The way to do this is look at each one of these these states and eliminate all those which have got an RL in it because we don't count. Now, there's no RL here, RL. This one here is there, so we eliminate that fellow. There's no RL here. There is an RL here. There's an RL here. There's an RL here. Right? Nothing there. There's RL all over here. Right? Here you got an RL here. You got RL here. You got RL. This is RR here. Sorry. So you have that. So how many have got an RL in it? You got 1, 2, 3, 3 and 4, 7, 7 and 3, 10, 11. So 11 ones are not allowed. 11 not allowed. Because here they face each other. So what are allowed? They've got 16 altogether. So 5 are allowed. So only 5 of these 16 will have that no man is then standing face to face next to him. So the probability is only 5 times out of 16 this will happen. So the probability is 5 over 16. Right. So that's the answer to the question. Express your answer as P over Q in its simplest form, where P and Q are integers. So this is P over Q. A simplest form, nothing cancels. So it's a simplest form. They're both integers. So that's your answer. So probability is, it's all about writing down all the possibilities, checking to see which ones are the successes, what I call successes. So the successes, there are only 5 successes here. All these ones which I wrote down are the failures because they are facing each other. And then you put the successes over the total number. So this is probability equals successes over the total number of possibilities. So just bear in mind, I'm sorry, this writing is so bad here. Probability is successes over the total. Now the successes were 5, right? Because what we circle is the failures, the total. Okay, so that takes care of that problem. And the next problem is we're going to number 7. Number So determine the ratio of the shaded area to the total area of the shape below, which is made of a square and semicircles. So, hey, this is a really weird area here. It's all snaking through this complicated diagram. So let's just analyze this diagram. You got a square. You have a square here. So there's your square going around like this. And then you got the diagonals of the square join. And then on this diagonal here, on this half a diagonal, you draw a semicircle. And this half a diagonal, you draw another semicircle. And here another semicircle. So there are 4 semicircles. And then you just shade in those pieces which have been shaded in. And what is the area of that? Right. And what is the ratio? So I need to add all the shaded areas. So if you actually oh okay, I was battling to get my pen right here. So if you think carefully, you got the ratio of the entire shape, which is made of squares. So if this is x and this is y, right? Then the shaded area, you notice all these are x by symmetry, and all these are y. So the shaded area is 4x plus 4y. Right. So that is the shaded area. But the question is, what is the ratio of the shaded area to the total area? So the total area is really 4 triangles. If I take this as a triangle, so all these triangles have the same area. Okay. So it's 4 of these triangles. So if you cancel the 4s, you'll have x plus y over a triangle. In other words, I need to only look at one triangle here and find what the ratio of that plus that, x plus y, over the entire triangle. So that is what I need to calculate. Okay. I don't have to worry about this entire complicated picture. I need to only look at a single triangle. And I've drawn that in the next slide, I think. Yeah. Okay. So what we need to do is, so there's I've got x. Okay, I'm calling this y and z. So what I need to do is I'm calling this X, I'm calling this part here Y, and I'm calling this Z, and I need to work out what is X plus Z. Remember, it's this part here. X plus Z over the triangle, the area of the triangle. So I'm giving names to this triangle. I'm calling it, doesn't really matter. I'm calling this one, I'm calling this two, and I'm calling that. This is a right angle triangle. Remember, you're looking at a square like this, and in a square, the diagonals, sorry, the diagonals of a square, they bisect the opposite angles. So these are 45, 45. So all these 8 angles are all 45. Right. So in particular, in this part here, this square here, this must be 45. And that is 45. So you have an isosceles triangle there. So if I call this 2, this whole thing here is 2. Right. Now, to calculate x plus z over, what is the area of the triangle? The area of the triangle is half base times height, which is 2. So this is what I need to calculate. What is x plus z over the area of the triangle? The area of the triangle we know is half base times. So we need to calculate x plus z. Right? We need not calculate x or z, but we need to work out x plus z. So how do I do this now? You see, so I noticed actually that if from this point here, if you draw a line, this is 90 degrees here, the diagonals of a square intersect at right angles. So a property of a square, you should know all the properties of a square. In a rhombus also, the diagonals intersect at right angles. But in a square in particular, so this is 90 degrees. So if you look at this thing, and from here, if you draw, if I take the midpoint of this, right, you will see that if I draw a perpendicular, it must go in there. It'll go from this point here. If I draw this, they will have to be equal. So this one here is divided into 2 equal parts. See? See, also the angle in a semicircle is 90 degrees. Well, okay, let's not go into the details of this. If it's intuitively, you can say this is 1 and this is 1. Okay. Now, why did I do this? Because I'm trying to calculate x, but I noticed that this part here is a quarter circle. This entire thing. So what you've got here is a quarter circle, and you've got a right angle triangle, and this is 1 here because this is 45, this is 90, and that is 45. So this length here is also 1. So you've got, I want to work out what is x. So we can see that x plus the area of this right angle. Now this right angle triangle is 1, 1. So it's half base times height, which is half 1 times 1. X plus that is the area of a quarter circle. And the area of the full circle, the radius of that quarter circle is 1. So the area of the full circle is pi r squared, which is pi. So the area of a quarter circle is pi over 4. So that tells you you can actually calculate x. Pi over 4 minus half. Right? And then, so that's x. Now, how do you calculate z? Now, z is a little bit more complicated because you'll have I need to get to z. So I can say x plus y, x plus this part here is half a circle. So x plus y is a semicircle. The radius of the circle is 1 again. So the radius of the full circle is pi r squared, which is pi. The radius of half a circle is pi over 2. So we can see what x plus y is. You can also see what y plus z is, because this plus z is the area of the triangle, which is half base times height, which is 2. So we know what x is. So therefore you can calculate y. Y is pi over 2 minus x. And we already had x is pi over 4 minus half. So you can simplify this. So you got y. So you know what y is. So therefore you can work out what z is. From here, that'll be 2 minus y. So it's 2 minus pi over 4 minus a half. Right? This is y. So you got x, you got z. So you can calculate x plus z. And divide that by 2. And that will give you the ratio. I'm not going to do all the those morbid things, but I'm giving you an idea as to how to solve it. It's not an easy problem. The hard part is actually saying that I can actually calculate what x is. Unfortunately, it's got pi and it hasn't got all whole numbers in it because you got a circle involved in it. So the good observation is that this part here, I got a triangle together with your x gives you a quarter circle. That tells you what x is. So once you got x, then you know x plus y is a semicircle, and y plus z is a triangle, and therefore you can work out all these areas to get to z. Okay, so that's the long and the short of that story. So let's get to the next problem. Right, a number line shows the integers from 0 to 100. So you got a number line which has got all the numbers from 0 to 100. Starting from 0, landing at 100. We'll just draw the first few. 1, 2, 3, 4, 5. Not drawn to scale, but like that. Right. Now Kermit begins at 0 and jumps one or more times to the right. Kermit is evidently the name of a frog. I think Kermit was the name of a frog in one of those cartoons. So he jumps to the right. So he jumps like that. But each jump is either 4 units or 9 units. So his first jump, he can jump to 4 or he can jump to 9. So Kermit can jump 4 or 9. And he keeps moving to the right. All right? Now, what is the largest number on the number line that Kermit could not land on? That's quite tricky. So let's see a possible sequence of jumps for Kermit. He could have had 4, the first one 4, then he could have had 9, and 9 again, he could have 4, and he could have 4, and 9, and so on. See? So after the first jump, he could have had 4. After the first 2 jumps, he could have had 8. After the first 3 jumps, he could have had 17, and so on. Right. Now, at any given stage, he would have jumped a number of 4s and a number of 9s. Right? And you don't know how many 4s and how many 9s he has. So here's the first observation. He lands on a number which is several 4s plus several 9s. So he lands on a number which is 4 times something. We don't know how many of that, so let's call it A. Suppose he lands A 4s, the number of 4s that he has in his jump, and 9B, where B is a number of 9s he has in his jump. Right? So if he landed here now, he would have had 4 fours, 16, plus 3 nines, 27. He would have landed at 43. Right? So this 4 fours and 3 nines gives you the number 43. So there are different ways of choosing A and B, and each time you choose A and B, it must be a positive integer. It could be 0. You could have had only 3 nines, for instance, and no fours, right? Uh, so A could be 0, but it's an integer. It's an integer which is either 0 or a counting number, and this is also an integer which is greater or equal to 0. So these are the possible numbers he lands on. So let's see now. The question is, what is the largest number on the number line that he cannot land on? Okay, the first number, the smallest number is 4. He can't land on 5, 6. No. Okay, he lands on 4. He doesn't land on 5 or 6. He lands on 8. Well, let's just put this down. 4, 5, 6, 7, 8, 9, 10, 11, 12. I'll just go up to this, or maybe 13, 14. You can land on 4, you can land on 8, you can land on 12, right? You can land on 9 if you took a 9 jump. Now here, you can't land on this. You can land on 13, 4 plus 9, but you can't land on 14. And if you go on, like for instance, suppose you landed on 40, right? So 40, now 41, you can land on 41. Why? Because 41 is 9 plus 32. Right. 4 eighths and a 9. So 41 is allowed. You can land on it. 42 is 18 plus 24. That's 2 nines and 4 sixes. So 42 is allowed. 43, that's 36, 27 plus 16. Now working it out mentally quite fast. 9 threes and 4 fours. So that's also allowed. And 44 is also allowed. So all these numbers here are all allowed. It turns out that every number here is all allowed. So the question is, what is the largest number on which you cannot land on? There is a number you can't land on. And from that point onwards, all the numbers you can land on. So what is that number? So it's quite a tricky problem. Okay, so how do you argue this? Right now, watch. I'm going to say, suppose you landed on a number 4a plus 9b. Right. Now my question is, does he land on the next one? Can he land on 4a plus 9b plus 1? Right. So it means that he has to reduce the number of A's and increase the ones, B's, or reduce the number of B's and increase the A's, right, to get to 1. Now, is it possible to get 1 involving 4 and 9, right? Like for instance, I'll just give you an example. If he removed 2 of the A's here, if he removed 8 and added 1, 9 and removed 2 4s, you're still going to get 4 times something plus 9 times something. So you could have removed 2 and 2 of the A's. So in other words, you removed 8 and you add 1 9. That'll give you plus 1, right? So reduce A by 2. and increase B by 1. And for instance, now if we landed at 43, we had, I think there we said it was 27 plus 16, so it's 4 fours plus 3 nines. 16 plus 27. Now to get to 44, I'm saying reduce this by 2, 4 twos, and increase this by 1, 3 nines, and make it 4 nines. Right? Increase this by 1. 4 nines is 36. 36 plus 8, 44, bingo. So you can reduce this by 2 or increase this by 1. That you could do. But you can also have, you see, to do this, really, the reason why that worked was 8 and 9 are consecutive numbers. One of them is a multiple of 9. The other number is a multiple of 4. And the next time this occurs, if you take 18 and its neighbors, neither of them is a multiple of 4. But if you take 27, you'll see that 28 is a multiple of 4. See? So you could have had increase A by 7 or increase A by 7 and decrease B by 3. Right? Because 28 minus 27. So you got 7 fours and you subtract 3 nines. Like for instance now, from I could have increased this 4 here. It's 43. Let's take this thing out. I could increase this by 7. So I could have had 4 11s and decreased that by 9, by 3. By 3. But if you decrease 3 by 3, you'll get 0. 0 nines. There it is. 4 times 11 is 44. Right? So the largest number that you can have is where you cannot decrease. You see, if you had, for instance, if you had 4 times 2 plus 9 times 1, you can't get to the next number. Oh, no, you can get to the next number because you can decrease this by 2. If I had 4 times 1, I can't decrease this by 2, right? And I can't decrease this by 3. I can't decrease either of the numbers. I can't decrease by 3, and I can't decrease A by 2. So you cannot get the next one. Although I got 4 plus 9 is 13, I can't get to 14. 14 is, you can't get to it because to add 1, I have to do one of these two things. So the largest possible number you can get, now this is a little bit tricky, is where you have 9 times 2, you can't decrease this any further, and 4 times 1, you can't decrease that 1 any further, right? So you'll have, that can be, that is obtainable. There's 18 plus 4 is 22, right? But you can't get the next one because you can't decrease this and you can't decrease it by 2 and you can't increase this by 2. And the next one is 23 is not attainable, right? But if you go on to the next one, 24, you'll have, you can try it out. You get 4 times 6, right? And then you'll have it's 24. And for 25, you'll have 4 times 4 plus 9, 16 plus 9, 25. 26 is 16 plus 10, 16 is 18 plus 8. So you'll have 4 times 2. See, you keep decreasing by this 2, and then you'll have 2 nines, 18 plus 8, right? But now the next one, you'll have 4 times 0, and you'll have 3 nines. Now you can proceed from here because you got 3 nines, you see. So you can decrease this by 3 and increase it by 7. So and then from that point onwards, everything can be obtained because you have enough A's and enough B's to get to the next one. As long as you've got enough A's and enough B's. But if A and B are too small, then you can't decrease. Right? Because you got too little. You must have at least two A's and you must have at least 3 9s, or at least 3 9s. All right, so the answer to this is 23. A very tricky and hard problem, but I hope you understand the logic of this. Okay, so we get to the next problem. That took quite a while. If you didn't understand it, it's going to be recorded, and it will be on the page. I think tomorrow maybe David might put it on, and so you'll have a couple of days to go over this. But as I said now, you will have completely new problems. The idea is, how do you think out of the box? So each time you have to figure out some way of arguing, right? But it's possible to argue. Sometimes the logic is a little bit difficult. Okay, now we go to question 9, the next one. In the diagram below, replace each letter by a different number from 1, 2, 3, 6, 1 to 8, 1 to 9. So what have you got? You got 9 boxes, right? You can see, and you must replace each of these numbers by one of these numbers here. So that the sum of the 4 numbers around each circle, so these 4 here will add up to 28, these add up to 17, these add to 23, these add to 25. Okay. And it's given that E is equal to 9. So the middle number is given. They say determine the other 8 numbers. It can be very difficult because if you do it by trial and error, suppose you know that E is 9, then you know that these 3 numbers add up to 19. Those 3 numbers add up to 8. Those 3 numbers add up to 14. And those 3 numbers add up to 16. And there's so many different ways in which you can get this. And you can try a particular combination. You see, it doesn't work with the others. So there must be some way of actually solving this problem. And okay, I took pains to do it. And I'm not sure whether I can remember because it's a little bit tricky. You can logically find the answer to the problem. You can actually say what A, B up to I are. All right. Okay, so what I've got here, I've written these things. I'll try to argue this thing out. The middle number is 9, so these 2 numbers add up to 17. Those 3 numbers add up to 17. So what I did was, I called the sum of these 2 numbers I don't know what these numbers are, but I gave a name to the sum. We call it A, right? Those two add up to A, the sum of these 2. Yeah, we don't know what A is. Now, in that case, this thing here can be calculated. It'll be the whole thing add up to 28. So those 4 numbers add up to 28. So 3 numbers will add up to 19. So this will have to be 19 minus A. Right? So then if this 19 minus A, then these two add up to 28 minus A. So therefore, those two add up to 28 minus A. So these two will add up to A minus 11 to get to 17. So if you add these four, the minus A and the plus A, I'll have to put a plus A here. And I got 28. How do I get to 17? 28 minus 11 will give you 17. All right. So what does this mean? It means that A minus 11, the A must be greater or equal to 11. Not greater or equal to, it must be greater than 11. So the sum of these two is A minus 11. So you'll have to have that A is greater or equal to, all right. So you argue it like this. You go step by step, and I'm going to show you how I did it. It takes a while because there are lots of possibilities you have to take. So there it is. So now you can see what I've done. I've come to the situation here. A, and I had a 9 here, and I said those four numbers add up to 28. Oops. So I came to this. Now, you see, A minus 11 must be at least 3 because these two numbers, they all come from 1, 2, 3, 4 up to 9. So the smallest possible value you can have is when both of them are equal to 1 and 2. So A minus 11 is at least 3, right? That's on the one hand. And at the same time, A minus 11 must be less than or equal to 15. Now, how do I, A must be less than or equal to 15. Oh, yes. You see, it's A here, right? That's the sum of these two. Now you got 9 here. So the largest possible value for A is 9. You can have 8 and 7. That's the largest possible value. So A is less than or equal to 15. And A minus 11 is greater or equal to 3. So therefore, A is greater or equal to 14 and less than or equal to 15. That immediately gives you only two possibilities for A. In other words, these two numbers, they add up to either 14 or 15. See? Right. So now we come to a situation where there are only two possibilities for A. And then I say, suppose A is 14. Right. Then I argue it out. If A is 14, what are the possibilities? You can have only 6 and 8. Two numbers adding up to 14. Right? You can't have 7 and 7. You can't have 5 and 9 because 9 is already taken. Right? You can't have 4 and 10 because the numbers are only from 1 to 9. So the only possibilities you can have are 6 and 8. But you don't know whether 6 is up there or 8 here, but it doesn't matter. You say that 6 and 8 are in this lot. Right? So once you do that, then you've got, you can calculate this one here. 19 minus 14 is 5. And 14 minus 11 is 3. So these two things add up to 3. The only way you can do that is 1 and 2. So now the thing is, you can have 1 and 2, or you can have 2 and 1. If you had 1 and 2, then if you this scenario, you have that. But this red ones mean that you're not allowed, because when you come to 13, you need to have two numbers which add up to 13. The only way you can get two numbers adding to 13 is 4 plus 9, not allowed because 9 is already taken, or 6 plus 7, you can't do that because 6 is taken. So this is eliminated. So then you say 5, 9, it has to be 1, 2, you see? And this time you got 12 here, right? And now for 12, you'll have 6 plus 6, or you're not allowed that. 4 plus 8, but you can't do that. 4 plus 8 is not allowed. 3 plus 9, that's not allowed as well. So this is out. So this 5, 9 doesn't work. If I got 2 and 1, 1 and 2 doesn't work. So then we say 14 is eliminated. See? 14 is eliminated. Okay, 9 is already here. So then you go to 15 now. The only way you can have 15 is 7 and 8. So you just put 7 and 8 here. You don't know where they fall. And continue like that. Right? And each time you come to a certain situation, you ask which two numbers add up to 12 or add up to 13, and so on. And if the number is already taken, then you can't have that possibility. So like that, you keep going on and on and on, and eliminate, and you get to this answer here. So the final answer is this one, right? And I'm not going to go through the whole process because we're already at 38 minutes past 6, and I've gone way beyond my time limit. Okay, so I'm glad to see we've still got 34 people here. I've got just one more. The last one is quite easy. So let me do that, right? I want to go to the number 10. You can see all these take a lot of time. That is why they give you 1 hour and you get 10 people. So one person can work on it and take a long time to get to this answer. All right. So the last one is you got a okay, I'll just give you the story. You got a grid like this, which is 8 by 8, and you're starting at this place here. This is your start, and you want to finish here, and you can move in any one of 3 directions, all towards the right. So you can, from any one position from here, you can move there or there or there, right? So there are many ways in which you can, but eventually you want to land up finishing here. So you could have started like that, and you could have gone like that, or you can come down to this. You're not allowed to go through these shaded squares. Then you have to come down like this, go like that. You can go like this, but you're not allowed to go up. So you're not allowed to go in here. You can only go in here like this and go in there like that. You're not allowed to go downwards, right? Or vertically upwards. You can only go to the right. Okay, so these are the possibilities. Now, there's a very important principle here in all these problems. The question is, how many pathways are there from here to there? I've just illustrated one, but there are many, many ways in which you can go from here to here. Now, how many possibilities, how many paths are there from start to finish? Now, you can see that can be quite a horrendous problem because there are so many different ways of doing this thing and you don't know where to start. And even if you start listing them down, you don't know whether you've already done one before, whether you're repeating it or whether you're missing anything out and so on. But there's a good important principle here. You see, if you got a particular square, let's just take, if you got a square, a point like this, or let's take a point like this here. You've got okay, so okay, like this. So if I want to fill in this, I'll put a tick. I'm going to put a number at each of these squares. Now, what number must I put? I could have come to the square from here, or from there, or from there. So whatever these numbers were, if there were 15 ways of getting to this, then you'll say it's 15. And if there are 10 ways and 3 ways here, then you can go 15 pathways use that square, 10 will use that square, and 3 will use that square. So altogether, you got that plus that plus that. There are only the sum of these 3 will give you the number of ways in which you can get to this square here. So whatever the number is here, the sum of those 3. Now, let's see, like for instance, starting here, There's only one way you can get to this square. From here to here. That's all. And there's only one way to get from to this and to this. Right. But now here, you can come from here, from there, or from there. So you can put 3 here. You see? 1 plus 1 plus 1. Right? And you can get to this square, but there's only one way, from here to here. Right? Now, if you look at this one, there's 0 here and 1 plus 1, so there's 2. So you have to add these 3 numbers, which are next to a square, to get to each one of them. Okay, and I don't know whether I've actually... Oh, I didn't write the answer. But try it like that now. I hope you understand what I said. The first few squares, I'll just fill in these so you'll have an idea. So these numbers are 1, 1, 1. And there's only 1 here. And here there's 2 ways, because 1 plus 1 and 0. And this is 3. And this is 2. And you can get down to this. There's only one way to do this. And you can't go here. You're not allowed to go. You're allowed to go horizontally. So there'll be a 1 here. But here you will have to have 6. And here you have to have 7. Right? And then here you'll have to have 14. And so on. You keep going up, then you'll know the number of ways you can get to any particular square. In the end, you'll get a number which finishes off here, and that is the number of ways in which you can get to that square. So eventually you target toward that square. But you have to keep targeting. So some of them are not attainable. You can't attain that one, for instance. So you can go all the way up to this point here like that. But if you go there, you can't come here anymore. Because to go down, you can only land there. So that would not be allowed. All right, so you can try that. So actually, so that's the way in which you can do that. It seems that I still got one more. And I'm going to finish this off. If some of you want to stay on, you can stay. So the last one is, again, a question of a gambling problem. He plays a gambling game. Now, when he gets a fair coin, right, when he gets heads, according to this problem, a fair coin is tossed 8 times, right? So you will have, maybe you got a head, tail, tail, head, head, tail, tail, head. So that makes 8. So this may be a possibility, right? Okay, so what happens is, he's got a certain amount of money. Suppose he's got X, right? Then each time a head is obtained, half the money he already has at that point is added to that amount. So in other words, if he gets a head, he adds X. Let's give you a number. Suppose he had suppose he had 28 rands. Start with 28 rands. Heads, he adds half of 28, he'll add it to this, he'll get 42. But every time he gets a tail, he loses half the amount he already has at that point. So the tail, it comes down to 21. Right. Another tail here will come down to 10 and a half. See, when he gets a tail, but then when he gets a head here, then you take half of this and you add it to the amount. Now, okay, it's sometimes you get fractions and all that. Let's not worry about that. But the point is that a tail, the next one will be half the tail. And head will be 1.5 times whatever you had here. 42 is 28 plus half 28. That's 1.5. So your original amount, your X, right? Depending on how many tails he's got, Right. So if you had 4 tails, then the x would have, halved, halved 4 times, x over 2, and that would have been halved again. So it would have been, x over 2 to the power of half, to the power of 4, if you had 4 tails like this, because it's half, 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 4 times. But then he's got 4 heads also. So the heads will be 3 over 2 to the power of 4. Right? So in this particular scenario, the amount of money he had, X, will go up to that amount. Right? Now, if he gets too many tails, then he's going to lose. If he's got a lot of heads, he's going to win. But now the question is, what is the minimum number of heads required to make a profit? Right? Now, we don't know. In this particular case, we had 4 tails and 4 heads, but he tosses it 8 times. So we'd have to say we don't know how many heads there are. Suppose T heads, and the number of tails will therefore be 8 minus T. I should have T tails. And so 8 minus T heads. Or rather, so we'll make it H heads and 8 minus H tails. All right. So your original amount X, it then becomes a half to the power of 8 minus H, right? Because you got 8 minus H tails, and 3 over 2 to the power of H, because it's got H heads, right? Each time you got a head, you multiply. But you want this to be, he wants to make an overall profit. In other words, you want this to be greater than what he started off with, X, right? So this multiplied by X, by the way. X is your starting point. So if you cancel the X's, you have this equation of 8 minus H, 3 over 2 to the power of H is greater than 1, right? And now you have an inequality, and you have to solve for H, okay? And this is so how do you do this? You got base. Let's get all the 3's together, and you have 3 to the power of H at the top, and at the bottom you got 2 to the power of 8 minus H, and then you got 2 to the power of plus H. If you multiply these and using the laws of indices, you get greater than 1, and 8 minus H plus H is 8, just 8, 2 to the power of 8. So you got 3 to the power of H is greater than 2 to the power of 8, and that is 256. So now the question is, what is the smallest value of H which makes this thing greater than 256? Okay, you'll see that if the powers of H now, when you quote 3 to the power of 5 is 243, that's not enough. So the smallest value of H is 6, right? 3 to the power of 5 is not greater than, doesn't work. So he has to get 6 heads. So that's quite a demand. He has to get 6 heads out of 8 heads to make a profit. Moral of the story, don't gamble. It might look as if you're getting, 1.5 every time you get a head. You say, hey, I'm making money here. But you're losing half each time you hit a tail. So that is why you're losing far more than what you're gaining, like every gambling sport. So in the end, you need to have at least 6 H's out of 8 to be to win, which says the probability of winning is very small, right? That is why they say a fool and his money are soon parted, especially gamblers. I'm very much against gambling, and I hope you guys don't ever go into a gambling den, give all your money to greedy politicians who are owning all the bank gambling dens. That is a fact. Okay, so guys, that is the end of this. Right? So we went through some rather hairy problems, but remember, the team questions, in the whole country, you got, maybe 400 of the top brains, metric brains, who are busy working on these problems. And I've never seen a single team getting 100 out of 100. Not a single time. The highest they ever get is 800, 8 out of 10 maybe, right? 10 people working together. So these are all team questions which I've got here. So you can understand these are quite, they're quite demanding. But if you do enough problems, right, you try to do the other problems as well. I've got in the problem book, I've got many difficult problems. Try them, and if you try, and if you fail, you can always write to me. I think I've given you my email address, and tell me, look, I tried this problem, but I can't solve it. Can you give me a hint? I would not give you the solution, but I'll give you the hint, and you can try that. And then, if you still don't do it, come back to me. So until you get to the answer, you must keep trying and trying. That's the only way you can do problem solving. I had to work for many hours to get all these strategies in place so that I can do some problems. Okay, thank you very much, guys. And I don't know, David. Again, once again, I abused my time, and it's now 5 to 7. Uh, the chat group, there are only three people of so you've got Jaintika,